In the previous movie, we added code to account for the possibility that a customer might need to spend more time at a station than planned. We changed our code to allow for a 5% possibility the customer would spend another randomly generated time period at the station. In this movie, we will run the simulation and see how adding rework loops to it affects our results. My sample file is chapter 0507, and you can find it in the chapter 5 folder of your exercise files collection. To recap, we didn't make any changes to the sim setup worksheet, although we could have stored the rework probability as part of the table that starts currently in cell A4, but we did make changes on the results worksheet. So I'll click that tab, and you see that over on the right, we have the customer ID, the station, and the amount of rework time. With that information in place, I'll press Alt F11, and we can move to the Visual Basic Editor to run our code. So Alt F11, then I'll click inside of the rework loops code subroutine, and then press F5 to run. And the code runs for a moment. And now I can press Alt F11 to move back to the workbook itself, and we should see the results worksheet. And we do. Over on the left, we have our previous results, which we have examined several times before. We can look at time and system, idle percentage, idle time, and so on. Over on the right, we have our rework information. So we have the customer ID, the station where the rework occurred, and the amount of time it took up. If you scroll down, you can see customers who had to go through rework loops. And it looks like we had two that had to go through two separate rework loops. So we have 120 twice, 153 twice, and I'll keep scrolling down. It looks like those were the only two who had to go through rework loops twice. That sort of thing will occasionally happen by chance. It just so happened that on this day, two customers had to repeat time at a station. If it is a consistent customer service issue, then you should examine it and see if you need to make some changes. On the other hand, if it was just random, but the customer is rightfully unhappy because the procedure took a lot longer than it should have, then you can offer them an incentive, maybe a free sandwich the next time they come in, or a future discount to kind of ease the pain that they went through because they had to spend more time within the system than they expected. In Chapter 5, we extended our simulation to allow for rework loops, where a customer spends more than the expected time at a station. In this chapter, we will simulate a related scenario, where a customer has a probability of moving to either Station 2 or Station 3 after they're done with Station 1. In both cases, the next station will be Station 4. So in this chapter, we will record probabilities of moving to one station or another. Now, of course, you can extend this technique to more branches in the process, but we'll keep it simple just for demonstration and do one. You could also add rework loops or other elements, but when you're adding multiple elements to a simulation, you need to make sure that each improvement works before you move on. Get a little bit working, make a backup copy of your workbook, and go on from there. In Chapter 5, we extended our simulation to allow for rework loops where a customer spends more than the expected time at a station. In this chapter, we will simulate a related scenario where a customer has a probability of moving to either Station 2 or Station 3 after they're done with Station 1. In both cases, the next station is Station 4. So even if a customer has to visit Station 2, they can skip Station 3 and go to Station 4. My sample file is Chapter 0602, and that's a workbook you can find in the Chapter 6 folder of the exercise files collection. I'm working with customer simulation and Poisson arrival data, like we've worked with in previous chapters. The difference on the sim setup worksheet is that I now have a probability column in column F, and that will be the probability of moving to a particular station. So we can go ahead and set in those values. The probability of moving to Station 1, which is required, is 1. Probabilities range from 0 to 1. Press Enter. Then in cell F6, we'll assume that a customer has an 85% probability of moving to Station 2. So I'll write that as a decimal, 0.85, and enter. The probability of moving to Station 3 instead is 0.15, so that will be 0.15, and enter. We could have also done that as a formula, subtracting the value in F6 from 1 to get the value for F7, but in this case I just typed it in. And the probability of having to visit Station 4 is 1, and that's the same for Station 5. These probability values need to be stored in a property for the station class. So I'll press Alt F11 to move to the Visual Basic Editor, and I have displayed the CStation class module. And you can see at the bottom of the variable declarations, I have probability as a single value. So this will be the probability, a decimal value, of moving to a particular station. And at the bottom of the class module, I have the get and let statements, which allow you to read and write data to the property. Now we can switch over to the code module and add code that will use the probability to determine whether a customer goes to station 2 or 3. So I'll go to the window menu and click module 2 where my code is. And I will scroll down to the place where I need to insert the new code. So I will scroll down and I will find the place that I marked to add my additional code. And the note is add conditional processing logic here and keep the object C station equals object C next station above the end if. So this is the statement that I will be keeping. Now I can add my code. So I will space in twice and add a comment, skip next station based on probability given in sim setup worksheet. And I typed a semicolon instead of a single quote, so I'll fix that. And we're there, and enter. There we go. This is an if-then statement, and I will use a randomly generated variable to determine whether to go to station 2 or 3. So I'll say if RND, and then open and close parentheses, is greater than stations, left parentheses, objc.nextStation. So the next station that the customer is scheduled to visit, dot probability, our new property, then, and enter twice, space in, objc.station equals objc.nextStation plus 1. So instead of going to station 2, they're going to station 3. And then I'll have an else. And beneath the else, it will be our original statement of moving to the next station. That is the end of this if statement. So I will go back, type end if, and we're done. So again, what we've done is say that 85% of the time, in this case, a customer will move to station 2. However, if the randomly generated value is greater than 0.85, which is the probability for station 2, then the customer will instead move to station 3. In this chapter, we have modified an existing simulation so that customers have an 85% chance of moving from station 1 to station 2 and a 15% chance of moving from station 1 to station 3. In either case, they will move to station 4 next. In this movie, we'll review our settings, run the simulation, and change some of the parameters so we can see how they affect our results. My sample file is chapter 0603, and you can find it in the chapter 6 folder of the exercise files collection. I won't review the changes we made to the VBA code. You can go back to the previous movie if you want to see them in detail. Instead, I'll just point out that we have the probabilities for moving to various stations. Stations 1, 4, and 5 must be visited, so those all have a probability of 1. However, station 2 will only be visited 85% of the time, on average, based on our analysis of this process, so its probability is 0.85. The complementary probability for the other possible station, station 3, is 0.15. So with all this information in place, let's press Alt F11 to move to the Visual Basic Editor. I'm in the Module 2 code module, so I can click inside of the Add More Stations subroutine and press F5 to run it. The code runs, and after a moment, I can press Alt F11 to move back to the workbook. And here I see the results on the results worksheet. We can see from the start in this simulation that we had a number of customers who experienced a lot of idle time early in the process. So customer 3 had over 26% of idle time, 34% for customer 10, and if we scroll down, we see it dips back down to 0, then up to 36, and we hang around in the high 20s, low 30s for a while. Then we have one customer who was idle for 52.33% of the time, so over half. Might want to take a look at that, why that happened. And the rest of the results show what I would think of as fairly typical performance within the system. To see how these results compare to a different run with different probabilities, I will delete all of the rows in this table below the first. I'll position my mouse pointer at the left side of cell A3 and click to select the entire row in the Excel table. Press Control-Shift-Down arrow to select the rest of the rows. Right-click, while my mouse pointer still looks like a right-pointing black arrow. Point to Delete and click Table Rows. And the table rows are gone. So now we can work with new results. Now I'll switch back to the Sim Setup worksheet. And let's say that instead of an 85% probability of moving to station 2, let's say that there's only a 50% probability, so it would be 0.5, and that means the probability for station 3 would also be 0.5. All my data looks good, and I already looked at my results sheet, so I'll press Alt F11, and the insertion point is still flashing within the subroutine, so I'll press F5. The code runs, and I'll press Alt F11 to move back. And we see very similar idle times at the start. In this case, we had 26.19 and 34.72 early on, but it does go back down to 0. So let's see if we get any results. 30 and 33, 39, 55, 37. So it looks like, in general, that we have reasonably comparable results. So even though 50% of our customers were going to station 3, which had a mean processing time of 30 instead of a mean processing time of 10, the overall idle time within the system and idle percentage doesn't look too bad. That's probably due to customers only needing to visit 4 stations overall rather than 5, but that's something that we can look at within the actual implementation of the process in your store. After you run a simulation or a set of simulations, you should take some time to examine the results to gain insights into the system you modeled. The code we've created in this course writes out information about each customer's progress through a series of stations within a process, but we could have just as easily written the information about stations and the time they spent idle or occupied. In this movie, I will show you how to gain insights into your operation by looking over a simulation's results as written. My sample file is chapter 0701, and you can find it in the chapter 7 folder of your exercise files collection. We're starting out on the Sim Setup worksheet, but we don't need to make any changes here. Instead, we can just look at the results from a previous run on the results worksheet. What we see here is a list of all the customers who have entered the system and when they left, what their current station is, whether they're idle, and the percentage of time that they remained idle within the system. One way to get information about the simulation results is to scroll through it, and you can look for values, especially in this case in time and system and percent idle. So if I start scrolling down, I'm going to look for large percent idle values, and I see here for customer 17, it looks like, 16, row 17, that customer spent over 36% of their time in the system idle, and 17 ticks idle out of 47 total. So that tells me two things. The first is that the customer did not spend overall a lot of time in the system. 47 looks to be fairly typical, but they were idle for quite a lot of time. However, we have a bunch of zeros around that 36.17% value, so that might have just been an anomaly within the system, a function of how often people arrived. So scroll down, see a bunch of zeros. 2%, we go back up for a while, around 20% idle, over 25%, back down to 0, then we get over 30% for one customer, and so on. So you get the idea. A visual inspection of your data can alert you to possibilities within it, and you can use other techniques to determine whether your first instincts are in fact correct. To be effective, a simulation uses random numbers to generate its results. After you run a simulation, you can delete its results from the results worksheet to make room for a new set of outputs. In this movie, I will show you how to delete rows from an Excel table so that you can run the simulation again with a new set of results. My sample file is chapter 0702, and you can find it in the chapter 7 folder of the exercise files collection. In this workbook, I have already run and saved a simulation. So I'll go to the results worksheet, and we see the data in the table. You've seen me delete rows from Excel tables before, but I always did it in passing. I wanted to explain the process in a separate movie so you can come back to here in case you forget the steps. The first row of the Excel table has data written in, but it also has two formulas, and those are in time and system and percent idle, columns G and H. So what we want to do is to leave one row, at least one row, within the Excel table, so those formulas will be preserved and copied down as results are written. To delete an Excel table row, move your mouse pointer over the left edge of the leftmost cell in the leftmost column of the Excel table. And in this case, that is cell A3. And you can see that my mouse pointer changed to a right-pointing black arrow. You don't want to be over the worksheet's row header. So if you move the mouse pointer a bit further to the left, you see that the row header is in fact selected. That's not what you want. Instead, you want to move a little bit to the right and be within the body of the table. Now you can click to select the row. See, it only selects the row within the table, and then select down to the last row of data by pressing Control-Shift-Down arrow. And that moves the selection down to the last row of the table. Now with your mouse pointer still a right-pointing black arrow, right-click, point to delete, and click Table Rows. And there you go. You have deleted all but one row from your Excel table, which means that you can now write your results and have the formulas operate as expected. Excel tables are useful and versatile tools. It's a shame more users aren't aware of them. One of the elements of Excel tables that I use a lot is the total row. You can add a total row to your table and use it to summarize values in a column. That could be finding the sum of all processing times or the average of customer idle time. In this movie, I will show you how to add the total row and change how it summarizes your table data. My sample file is chapter 0703, and you can find it in the chapter 7 folder of your exercise files collection. I have already run the simulation, so I will switch to the results worksheet. To display the total row, make sure that a cell within the body of the Excel table is the active cell. Then go up to the Table Design contextual tab of the ribbon, and in the Table Style Options group, check the Total Row box. You can see that at the bottom of the table, we now have a total row. By default, Excel creates a sum calculation in the bottom right corner. So you see in the rightmost column, we have percent idle with a total of 603.53%. Now, percent idle as a total doesn't make a lot of sense, so let's switch that to average. I'll click the cell that contains the calculation under percent idle. Looks like that's column H of the worksheet. I'll click the down arrow, and I can select from the operations that I want. If I don't want any calculation, in other words, the cell will be blank, I can click none, or I can select anything else, but in this case, I want average. So I see that on average, customers spent 4.19% of their time idle. That doesn't seem like a bad result. In fact, I would probably be pretty happy with that. If you want to add calculations to other cells within the total row, you can do that. So let's say that I want to find the total that individuals were within the system. So that would be time and system. I'll click the total row cell one to the left, click the down arrow, and click sum. And there's the total. Customers spent a total of 6,709 ticks within the system. If I want to find the sum of idle time, I can do the same thing, click one to the left, down arrow, sum, and we see the total idle time was 245 ticks. And again, whether those results are good, bad, or neither depends on your expectations for your system. When you're done working with the total row, you can go up to the Table Design Contextual tab, clear the checkbox, and the total row disappears. While your workbook is still open, if you check the total row box, then your calculations will come back. They aren't saved if you quit the workbook and reopen it, but as long as you're still working in the same session, your results will be there. Excel tables let you analyze your results in many ways. Two of the techniques you can use for your table data are sorting and filtering. Sorting lets you change the order of your data based on the values in one or more columns, while filtering lets you concentrate on just the results that matter to you. In this movie, I will show you how to sort and filter using an Excel table's filter arrows. My sample file is chapter 0704, You can find that in the Chapter 7 folder of the exercise files collection. We've already run the simulation, so I will go to the results worksheet, and there we have our Excel table. Let's say that I want to find customers who left before the customer that immediately preceded them left the system. So in other words, a customer came in, customer number 2 followed them, but customer number 2 left before customer number 1 did. To get that information from this table, I can sort the left system column from smallest to largest. So I will go to the left system column, click its filter arrow, and the top item is sort smallest to largest. I see 3 customers at the top who never left the system, so that means that they came in too late to make it all the way through, so we can ignore them. And let's take a look below to see if we have any customer IDs out of order. So I'll scroll down, and I see that customers 16 and 15 are reversed. So customer 16 came in 18 ticks after customer 15 and left 1 tick before them. If we wanted to, we could look for similar occurrences elsewhere in the data. Now press Ctrl Z to undo the sort and go back up to the top. And now I will filter. Filtering is a way to focus on the data that you really care about. Let's say that I only want to see rows where customers were idle for 10 or more ticks within the system. To create that filter, I can go to the idle time column, click its filter arrow, point to number filters, and then click greater than. Let's do greater than or equal to, so 10 or more. I see that I have an idle time is greater than or equal to, so I'll type 10 and click OK. And I see that I have a total of 6 customers who were idle for 10 or more ticks within the system, and their percent of idle time was pretty high. So it means that they moved through the system quickly, but it could have been even quicker if we'd been able to get their idle time down. To clear a filter, go to the filter arrow again, click Clear Filter from column name, in this case idle time, and you're done. Creating a simulation can be tricky, whether you do it in Excel or another program. In this movie, I will describe some of the mistakes I've made over the years, so you can avoid them in your own work. Most of this movie will be description, but if you'd like to follow along, the first exercise file I will use is Chapter 0705, which you can find in the Chapter 7 folder of your exercise files collection. I'll go directly to the VBA code, so I'll press Alt F11 and look in Module 1. One mistake that is very easy to make is mistyping the name of a variable. Because the mistyped variable doesn't get the value you expect it to, you get a lot of zeros, subscript errors, and so on. You can avoid that problem by placing the option explicit statement above the beginning of your subroutine. Option explicit requires variable declaration before you use them, so that means that if you misspell a variable name, you'll get an error and you'll be able to look up and fix the problem. Another mistake you can make is to not really have random values generated when you think you do. So if we scroll down within Module 1 and take a look at the code, and this workbook originally came from Module 2, we'll see that we generate the amount of time that a customer spends in a station. So we have a random processing time with a random number, and then we use the inverse function based on the normal distribution to decide what that actual output was, based on an average and a standard deviation. The problem with just using R&D is that you get a known string of values. It always comes out the same when you restart the program. To demonstrate, I'll press Ctrl G to open the immediate window, which is where debug.print, seen here, outputs the processing times. With the insertion point in the subroutine, I'll press F5 to run, and look at our first 3 values, 20, 10, and 16. If I close everything, so I'll close out of the Visual Basic Editor, and then I'll press Ctrl W to close the workbook, then Ctrl O, and I will open it right back up. I've reset the workbook, and if I press Alt F11 to move back to the Visual Basic Editor, and I'll click over to Module 1, I will delete the values in the immediate window, click back up in the subroutine, press F5, and we get exactly the same string of values. You can fix that by adding the randomize keyword, and I have made a note for myself to put that in. So if I scroll down in module 1, I see that I have a randomized results statement. So I'll type randomize and Control S to save. So remember, our first three values are 20, 10, and 16, just like they were the last time. So I'll close the Visual Basic Editor, Control W. All right, everything was saved, so we're fine. Control O, reopen the same file. Alt F11. I will delete the contents of the immediate window. Switch over to the code module, click inside the subroutine, F5, and we get a different set of values. So if you're using R&D within VBA and you don't have any other random values coming in, always add randomize so your results will be different between runs. For my last two items, I will close this workbook and switch over to Chapter 04 Complete, which contains all the code from Chapter 4. So I'll go ahead and close here. I'll close the workbook by pressing Control W. I'm not closing Excel all the way. Control O, and I will open Chapter 4 Complete and enable its macros. One is in VBA, so I'll press Alt F11 to move to the Visual Basic Editor. My immediate window is still open, so I'll go ahead and close that. One mistake that I made, and which I discussed earlier in the course, was to have a 0 or negative processing time for a customer at a station. I had to make sure that value was at least 1. So if I scroll down and I look at processing time for a customer in a station, you see here that I needed to add the code to make sure that a customer spends at least 1 tick in a station. So basically what I did was I did an if-then. If the value of the end time was less than the ticker value, then I made a ticker plus 1, so they would spend at least 1 tick in the station. There's another error that I made that I actually didn't catch until I was done recording this course. And I want to admit that was a problem and show you what I did so you can avoid it yourself. I'll press Alt F11 to move back to the Sim Setup workbook. And if you look over on the right in columns L and M, you see the Poisson arrival data. And you notice that the top value in L2 is 0. So what that means is that there is a very small but very real chance that a customer would have an arrival time the same tick as the previous customer. When that occurred within one of my simulations that I was running as a test, I didn't realize what had happened until I looked back here. You get a similar problem to what we had if a customer spent 0 or negative time at a station, except in this case, only that customer got stuck and others were able to work around them. The best way to fix this issue is to simply not pull up a 0 value. So what you can do is go to cells L2, M2 and select them. Then on the Home tab, click Delete. And you see that the lowest value you can look up now is 1. So that's the best way to fix that. It's kind of embarrassing to admit that I made these mistakes, but the benefit is that you